Okay, so here I am. I'm going to finish up the sheet from today. So I am on number 6 here. So they give us, guess I got to share my screen. Yes, I'm on number 6 here. So now what they're doing on this one is they're giving us not the sine theta and the cosine theta, but they're giving us a circle. With this little over here, and we're saying the point is a comma 2. That's an A. That's my theta. And my circle is x squared plus y squared equals 5. So maybe just recall, for a circle, you have x squared plus y squared equals r squared. So in this case, that 5 is not your radius. That's your r squared equals 5. So my r is root 5. So we're going to need that. So I'm going to go ahead and circle that right here. Also, what is this a? I guess I know that a squared plus 2 squared equals 5. So a squared plus 4 is 5. Or my a squared is 1. And a would be either plus or minus 1. But again, we're taking a look at where a is. You see the quadrant. You see it's negative over here. So we're going to take the negative, and I'm going to say then that I'll just write it over here. A equals -1. So that's this coordinate right here, -1, 2. Okay, so what you're going to end up needing then is, I guess, sine theta and cosine theta. So maybe, again, just recall, I'm going to say sine theta is y over r, and cosine theta is x over r. So I have sine theta is 2 over root 5, and cosine theta is -1 over root 5. And these are the two things that I'm going to use to get all my answers. Cosine 2 theta, theta over 2, sine 2 theta. So all I'm going to do here is apply the identities and plug everything in. Okay, so my first problem here says to find cosine of 2 theta, which is cosine squared theta minus sine squared theta, -1 over root 5 squared, minus 2 over root 5 squared. And I have 1/5 minus 4/5, which is -3/5. And it makes sense that it's negative, because if I look back on my circle here, right, this is theta. If we went double theta, we would end up over here somewhere, and I should get a negative value, right? For cosine, because cosine is the x coordinate. Oops. Okay. The next one has me find cosine theta over 2. Right? Which would be plus or minus square root 1 plus cosine theta over 2. So I am going to be worried about which quadrant I'm in, so whether or not I'm positive or negative. So instead of looking back up there, I'm going to say, well, if theta was over there, half of theta is going to be smaller. So where 2 theta actually stuck me over here in this quadrant, half of theta sticks me over here. I didn't really have to worry about it in this one because I didn't have the plus or minusness. It just, at the end, I got negative and I noticed that it was okay. But here, I do have to pay attention because there's plus or minus that I would be here in quadrant 1, which is going to mean I'm going to take the positive value here. Then I'm just going to plug it in. Cosine theta was -1 over root 5. So same deal, multiply top and the bottom by root 5 to get rid of the fractions in my fraction. And I have square root 5 minus 1 all over 2 root 5. And actually, I didn't do a very good job here, but this square root is all still over the whole thing. Mostly just applied my idea. The only thing I really needed to notice right there was that it was positive. Okay, so there goes my answer for that one. Okay, the next one has me find sine 2 theta, and that's gonna be nice. Again, I'm not gonna need to worry about the plus or minus. I'm just gonna say, well, that's 2 sine theta cos theta, and I just found my sine theta and cosine theta, so I'm just gonna plug everything in. And 2, 4, -4 over root 5 times root 5 is 5. So that one's nice and easy. Not even any simplifying to do. Yeah, I like that one. Okay. Then they want us to find the sine of theta over 2, which is plus or minus root 1 minus cosine theta over 2. Again, remembering that we were in quadrant 1, right? Theta's over here, half of theta is going to be over there, which means that I am going to take the positive value. All over 2. Maybe I'll just get rid of that minus negative because that's weird to look at. But then multiply top and the bottom by root 5. And I have my answer. So it's really similar to the ones we were doing earlier, and I believe it was number 5 there. The only real difference is that they didn't just give me cosine theta. It was not on the unit circle. So since my point was not on the unit circle, I had to go find my r and make sure my sine was 2 over root 5, not just 2. And my cosine was -1 over root 5, not just -1. Because of that 5. All right. So that's number 6. And I guess the last one we have is number 7. And number 7, I believe, just says to establish the identity. Neat. I don't know if y'all can hear a lot of those songs in the background. So here's the identity we want to have. We have sine for theta equals 4 sine theta cosine theta times cosine 2 theta. So what I'm going to do is I'm going to start here with the left-hand side. I guess what I want to, that this is 4 theta is twice 2 theta. Right? So when I apply the old this one, sine 2 theta equals 2 sine theta cosine theta. But if it's sine 4 theta, I'm going to have 2 sine 2 theta cosine 2 theta. And then I'm going to do it again on this guy. So I have 2 times 2 sine theta cosine theta. And my cosine 2 theta is still right there. Geez. And then 2 times 2 is 4. And if I look up here, this is indeed the thing I was trying to get. Okay, so there you go. Finish off the sheet. You guys have a good weekend. And, you know, again, contact me with anything. I'll make sure I pass it along to whoever needs to hear it.